I'm honored to be here to accept this on behalf of Deeya. This is the second time Deeya has won a TiEcon50 in 2009 before, so we're doubly honored to be here again. Let's see. There we go. So I wanted to give a background a bit on Deeya and then tell you about the value proposition that we're serving. We're an energy storage company targeting the stationary energy storage market. Our product you would not see on the back of a Tesla or in an Apple iPhone, for example. You would see it more on a ground-based application. And where we're focusing is on wireless telecom, particularly in the emerging market. Our business is primarily in India. So we're a California-based company with most of our sales and operations in India. So being here at TiEcon is doubly sweet. What our technology is a flow battery, and I'll show a diagram to explain what that is. It's physically like a fuel cell, but you have moving fluids and chemicals in a recyclable chemical reaction. And where today in that application, the cell phone towers, they'll use consumable lead-acid batteries, we turn that into a capital asset that lasts 5 years. So why do people buy our product? It saves them money on diesel fuel. The largest operational cost at cell phone towers in emerging markets is diesel fuel to run the generators that provide electricity. We roughly save them about half, and it pays back for itself in about 2 years. And our business, as I said, it is in India, Bangladesh, and East African countries. So the team, myself, I'm primarily a semiconductor manufacturing guy, although I previously was in the solar industry for several years, and the rest of the team comes from a variety of good backgrounds. In particular, our team in India, they are India wireless telecom people, so a really strong team there in our India operations. And where we are is our current product is going into the field now in small commercial volumes, and we're working on our next generation product. Just to acknowledge our very great investors, NEA, Blue Run, DFJ, Tech Partners, and Element Partners. And there was some press last week or the week before that we had raised another round, which is true. We have raised another round of funding. So we're a two-location company. We're in Fremont, right on the border of Milpitas. And then in India, we're in Gurgaon. So here in Fremont, it's basically engineering, headquarters, finance. And in Gurgaon, that's actually where we make the product, sell it, service it, and have some engineering as well. And you can see our manufacturing floor, all the white boxes. Those are our energy storage platform products being built. So just to give an idea of what's the value proposition. Today, there are about 1 million cell phone towers in emerging markets, and a majority of those run the vast majority of the time on diesel generators. There's either no grid, or where the grid is connected, the cell phone towers companies cannot rely on it because it's too unpredictable. Those of you who are from India or have done business in India, you know what I'm talking about. The grid goes down a lot, and in a lot of places you simply can't rely on it. Cell phone tower companies are held contractually to have 7x24 coverage or pay really brutal penalties. So primarily they rely on diesel generators to keep these things going. The typical cell phone tower site will have a little white building with all the cell phone tower electronics in it. Also lead-acid batteries, they're there as a backup. They typically last less than 2 years due to the way this thing operates, and those little buildings often are air-conditioned to provide lifetime for the batteries and the electronics. It's expensive, it's inefficient, and you have to deal with the recycling and the cost of lead-acid batteries. In the case when now you substitute Deeya technology, you have now what is a 5-year lifetime product. We actually provide power 50% of the time. While the generator's running, we get charged. We shut the generator off, and we actually provide the site. So we're not just a backup. We're actually a secondary energy source. Charges quickly, lasts many cycles, tens of thousands of cycles, and so it's a 5-year product. Roughly powers the site half the time. So what that means is essentially the customer, the cell phone tower operator, is saving about 50% on their largest operational expense, which is diesel fuel. And me as a solar and environmental guy, of course, it's cutting back on CO2 production about 50%. So it's great. Interesting, me coming from the solar world to this world, this is a market where the sale is because it makes money for the customer. There's no government incentives involved in this, which is, as somebody from the solar world, that's still pretty amazing to me. Just a snapshot then, what is a flow battery? On the top left gives you an idea. It looks a lot like a fuel cell. There's a membrane, there's a plus and a minus side, except in this case, there's 2 tanks of electrolyte liquids that are constantly flowing. When the reaction is going one way, it's discharging, that's putting out power. When the reaction is reversed, you flip the polarity of the electrodes, it is being charged by the generator. And so it's just a reversible redox chemical reaction. We have a bunch of interesting IP, but the original idea of the redox flow battery and this chemistry came from NASA. What we have done is put a lot of our own IP into it and a lot of clever things around the items I have listed there. And then just to give you an idea, here's one site. You know, we have quite a few sites in India where you can see the relative size of our product compared to the little buildings, the shelter, and the diesel generators that are always there. And you can see the size of our unit's about like a double-wide freezer. You would definitely not put this on the back of a Tesla. That would be uncool. So, you know, the typical time we've had these out there now is a couple years. We're starting to put more in the field. And the graph is just showing you the energy savings from several example sites. Okay, so thank you very much.